What is the K-value of PVC resin? This is a standard Schedule 40 pipe made up of resin having a K-value 67, and this is a standard Schedule 40 fitting made up of resin having a K-value 60. Or both of they have same strength? If not, which one is better and why? Different grades of PVC polymer are used in the manufacturing of pipes and in fittings. Also, today we will investigate where we can use K66 or even K65 grades of PVC resin. Hello and welcome back to my channel. Today we are going to talk about the K value of PVC resin. PVC or polyvinyl chloride is a polymer made up of small units of vinyl chloride monomer through a process called polymerization. The K value is an indication of the molecular weight or the chain length of the polymer. It is determined by Finch's K-value method and indicates the viscosity and the melt behavior of the resin. The more the K-value of resin, the longer its chain will be, or it will have the more molecular weight. K67 resin is commonly used to manufacture the pressure pipes because it shows good mechanical strength due to high molecular mass, which help the pipe to bear the pressure more conveniently. Also, it shows better fusion during the process because long chains interlock in a better way, resulting the high tensile strength of the pipe. But if we want to use our pipe for sewerage or drainage purposes, we can use the relatively lower grade of the resin. For example, we can use K66 or even K65 grade for our SWV pipes because there is no need to bear the pressure. Although the K67 resin has a more tensile strength as compared to K66 and K65, but there is a challenge in the processing of K67. As we know, the long chains of K67 resin entangled, resulting in elevated temperatures and pressures during the process, which results in the more power consumption. For injection molding fitting of uPVC material, we use K60 grade of the resin. Here a question arises, if the K67 resin is so super, then why do we use a relatively lower grade of resin for our molding fittings? The answer is simple. K60 resin is relatively of less molecular weight as compared to K67 resin. So it shows less melt viscosity and better flow, which is required in injection molding. As we know, the molten material needs to be filled in the complex dies of elbows, sockets or T's, especially when we want to prepare the fittings for electrical conduits like the complex junction boxes or the fan boxes. The openings in the die are very narrow and requires a material that can flow through them easily and conveniently. Also, the molds fill quickly and completely, reducing the risk of shorts. Also, there is another advantage associated with it, as due to its less viscosity, it needs less processing temperatures, resulting in the more energy savings. Here is a question arises, how would we encounter this strength lag in between the fitting which is made by K60 resin and the pipe which is made by K67 resin? So, to encounter this, we need to maintain the wall thickness of fitting to 125% the wall thickness of the pipe, which is recommended by ASTM standards. Also, we need to add more impact modifier in the formulation of fitting. So, to encounter that strength lag, I hope you find this information to be useful. If you do, consider subscribing to my channel, hit the like button and share this information with your friends and colleagues. Until then, take care.